In this third and final part of the video program, we'll focus on gravel road maintenance equipment and techniques. Beginning with equipment. The motor grader has traditionally been the workhorse of gravel road maintenance, and for good reason. It's a venerable and versatile piece of machinery that has been gradually improved through the years. Articulation is one such improvement, one that greatly increases the grader's maneuverability and effectiveness. Of course, there are many different makes and models of motor graders. Perhaps within your own agency there is quite an assortment. Not all of them have the same features, including articulation, but all can accomplish the same basic tasks in maintaining gravel roads. Smoothing, reshaping, and regraveling the roadway and shoulders, and cleaning ditches. Let's look quickly at each. Smoothing a gravel road may also be termed blading or dragging. It's a routine maintenance operation aimed at restoring a road's crust by collecting loose fines and gravel and respreading them evenly. The fines and gravel break loose because of normal traffic action and weathering. After this loose material is spread, traffic recompacts it to form a tight crust if moisture is present. Smoothing may eliminate minor surface irregularities, but isn't intended to correct the more severe or extensive defects. Reshaping, however, is. It involves cutting and remixing the surface materials to restore the crown to its original shape. Rather than just collecting and respreading already loose material, reshaping cuts deep enough into the surface to eliminate defects and thoroughly remix the gravel layer. Reshaping is needed when mere smoothing will not restore the surface adequately. For example, following heavy rainfalls or in the springtime. Multiple grader passes are required to properly remix and reshape the roadway, including shoulders. Regraveling is the adding of new gravel to replace material that has been lost from the surface. It's a reconstruction operation that involves more equipment than just the grader, including dump trucks for placing gravel, and ideally water trucks for adding moisture, and rollers for compacting the new gravel layer. Before new material is brought in, the existing surface should be scarified to prepare it to blend with the gravel to be added. Moistening the surface with water is advisable at this point. Then the grader operator usually sets stakes or other markers to indicate the spread distances for truck drivers to dump their gravel. The drivers try to dump their loads from the end of the previous pile right up to the next marker. Next, the grader operator works these piles into an equalized windrow, remixing the gravel to minimize segregation and leaving the gravel ready to spread laterally to a uniform depth. Then the operator begins spreading the gravel by cutting it from the equalized windrow and working it across the roadway. Many passes are required to spread it evenly. Water should be sprayed on the surface during final spreading, shaping, and compacting, both to aid in producing a dense surface course and tight crust, and to control dust. The surface should be rolled after the grader's final pass to compact the gravel layer and to form the surface crust. Now, not all regraveling is of the scope you see here, of course. On this job, enough new material is being added to require 2 lifts, each about 80 millimeters thick. Finally, because of the importance of drainage to gravel roads, ditch cleaning is as critical to road maintenance as are smoothing, reshaping, and regraveling. Cleaning ditches with a motor grader involves removing obstructing materials and restoring flow lines so that water draining off the road will then drain away from the road. So these are the basic tasks in maintaining gravel road surfaces with a motor grader. It takes a lot of skill to operate a grader. One thing that operators need to do well is use the proper gears and speed for working and traveling. In Part 2, you saw an example of working in the wrong gear and at excessive speed. As a result, the bouncing grader's moldboard made diagonal corrugations in the road surface. So for both quality of work and safety, graders should work at about 5 to 8 kilometers per hour and travel according to the posted speed limit and actual road conditions. Other safety practices need to be followed as well. Signing and marking work areas. Making sure that graders have the required warning lights, placards, and alarms. Working in the direction of traffic. And observing the operator's own safety by remaining seated while operating, using a seat belt, mounting and dismounting the machine carefully, and so forth. The main tool of graders is the moldboard. Attached to its bottom is the blade or cutting edge, 2 or more replaceable sections that take the brunt of the wear and tear. Moldboards are adjustable for angle, pitch or tilt, and downward pressure. They can be side shifted, or even placed in the bank position. All of this flexibility is for a purpose: to enable the grader to put the moldboard where it's needed to perform the cutting, shaping, mixing, or spreading that's required. Another tool on many graders is the scarifying attachment. It's used mainly to rip and break up surfaces, but also to blend materials together. Seeing the need to make moldboards and blades still more versatile, certain manufacturers have developed specialized scarifying blades. We'll cover 3 of them here. Caterpillar's grader bit system features fixed teeth or bits that are replaceable and have different widths for different operations. The number and spacing of bits can be varied for different uses. John Deere's Stinger system employs round bits that rotate, are likewise replaceable, and can be variably spaced. Sandvik System 2000 is another type of scarifying blade that uses round rotating bits. These bits, and the others, are made of carbide steel for longer wear and greater resistance to abrasion. The scarifying blades reportedly penetrate, screen, and smooth better than conventional cutting edges. For example, a hard, uneven surface can be cut and leveled more easily. Also, the spaces between bits leave the fines with the gravel instead of separating them. In addition, less expensive pit run material available in some areas can be used instead of more costly processed gravel because the bits screen out the oversized rock and waste it on the shoulder. In effect, the scarifying blades process the pit run material in place. Altogether, scarifying blades may lower maintenance costs by maintaining more road with the same time and effort, reducing machine time and labor costs, reducing new gravel costs, and producing better maintained gravel surfaces. If interested, Local agencies should investigate and decide for themselves. Now, in addition to some traditional machines that have supplemented motor graders, such as drags and rakes, there are some new pieces of equipment out there. For instance, Borgen Sales in South Dakota manufactures the Quick-Tack Road Leveler, a scarifying blade attachment for the front snowplow lift of graders. It combines a mold board and fixed cutting teeth, something like the scarifying blades we just looked at. Then there's this rock picker developed by Glenn Mac Harley that picks up an entire windrow of surfacing material, separates oversized rocks, and conveys them to a truck, and drops the smaller screened gravel back on the road. The problems of shoulder maintenance on gravel roads can be addressed by equipment like the Retriever, manufactured by AVF Railtie Limited of Canada. It's a disking machine designed to mulch shoulder vegetation, level berms that typically form along shoulders, and retrieve gravel that has collected there. Traditionally, the grader's mold board has been used to pull shoulders. But this practice typically creates maintenance windrows that restrict traffic and drainage. We'll look a little more at this issue in a few minutes, but for now, be aware that the Retriever's intent is to avoid creating these windrows. While another new machine, the Windrow Pulverizer, is designed to process the windrows, breaking up the sod clumps and vegetation so that the materials can be spread back across the travelway. This equipment is manufactured by the Canadian firm Triple S Industries. So in addition to the old workhorse and assorted drags and rakes, there are some newer machines that merit consideration by local agencies. Let's turn now to maintenance techniques. It might be more accurate to call these tips or pointers, and some have been touched on earlier in the video. The first one has to do with proper moisture content of gravel surfaces. Moisture is an ally of gravel roads in several ways. It helps bond gravel particles together, aiding their compaction into a dense mass. When a moist surface is rolled, it forms a thick crust that will then repel rain. And as you well know, moisture suppresses dust. The best time to work a gravel road is the day after it rains. In fact, the only time that a gravel road should be reshaped is when it's moist. If nature doesn't provide moisture, the only way you should work on the road is if you're able to put a water truck on it. Sometimes routine blading may have to be done during periods of prolonged dry weather. If so, only very light blading should be done, never cutting or reshaping. If you cut or reshape a dry surface, the next vehicles to drive by will kick out the fines and you're back where you started. Another point, gravel road reshaping should always include smoothing the surface all the way to the ditch line. Leaving even slight ridges of material along the shoulder can lead to the forming of double or secondary ditches. Runoff then won't reach the ditch, but will build up on the travelway and begin eroding it. You've already seen maintenance windrows in this video, and we've discussed them briefly. They're formed and left on roads for two different reasons. One type is created when shoulders are pulled and the clumps of sod, clipped vegetation, and reclaimed gravel are left in a berm along the edge. Since agencies don't want to spread these large clumps of debris across the roadway, and rightly so, they leave them in the windrow to rot and dry first. Then the material can be used to maintain the surface. Another type of maintenance windrow consists only of excess gravel that's usually stored there during prolonged dry weather. When moisture comes later, this material can be used to replenish the surface. But regardless of why they are there, maintenance windrows should be kept to a minimum because they restrict traffic as well as drainage. Some agencies have policies against leaving windrows at any time. Next point. Ditch cleaning and shaping should be done frequently. Proper ditch maintenance is a key to keeping roads in good condition. Even when there's no maintenance windrow or double ditch to block or intercept runoff, blockage in the ditch itself can keep water from properly flowing off and away from the road. Culverts need to be kept open too, usually requiring some shoveling to supplement what the machine can do. Finally, gravel roads need to be shaped to match intersecting roads, railroad crossings, bridges, and driveways. Loose gravel must be kept off of paved surfaces and bridge decks, and especially railroad tracks. By increasing their awareness of both the causes of gravel road problems and the means of preventing and correcting them, local agencies can improve their maintenance of a vital portion of our nation's highway network, and thereby better serve the traveling public throughout the land. This presentation has been brought to you by the Local Technical Assistance Program, LTAP. For further information, contact your state's Technology Transfer Center.